Hello everyone, welcome back to Atomic Ascent, the place where chemistry becomes simple, logical, and truly fun to learn. If you are a student preparing for competitive exams like JEE, NEET, and other entrance tests, or you simply want to build a strong command over chemistry concepts, then you have just landed in the right classroom. So grab your notebooks, stay focused, and let's begin our journey of mastering chemistry one concept and one question at a time. Let's get started. So, our today's topic is reactions in solutions. Now, what is the need of this studying about this topic? That most of the reactions when we do in the chemistry, you might have seen we have made a different kind of solutions or different chemicals. So these reactions, what are happening in the aqueous solutions or any kind of solutions, we are going to talk about it. Let's go back to the history of little bit about solution. Okay, as you know, solution is a homogeneous mixture. Okay, it is a homogeneous mixture. Okay, remember, and it is mainly whenever we are talking about a solution, we are talking about a solution or homogeneous mixture which has two components. Okay, the solution with two components is known as binary solution. Okay, so it is not like only two components are present in the solutions. Solutions are made up of number of components also. Like if three components are there, then it is called ternary solution. Okay, three components are there, then it is called ternary solution. Okay, if four components are there, then it is called quaternary solution, and so on. So solutions can be of different types depending upon the number of components in them. In our syllabus, mainly binary solutions are there, so we are going to talk about them only. Let's take a few examples for understanding that what are solutions. So very simple example is that if you take water and then you add salt to it, what happens in that? The water and salt, they get dissolved. Salt actually get dissolved in water, and a binary solution, okay, it is formed, which is known as salt solution, right? It is known as salt solution. Fine. So this is first binary solution. You can make this binary solution with water and sugar also. Fine, there is no problem. You can take alcohol and water also. You can take alcohol and acetone also. So these are binary solutions. Okay, when we are mixing two components and they are mixing with each other in such a way that their composition becomes throughout that mixture equal, and we cannot identify them easily, that which one is which component. Okay, that is called a solution. Okay, binary solution is there. You can take multiple solutions also. If you talk about stainless steel, SS, okay, you might have heard about it. What is the stainless steel? Okay, so stainless steel has iron in it. It is the major, okay, metal in it. then we add carbon, okay, then we add chromium, right? So we can add a lot of different things also, like nickel we can add molybdenum, we can add manganese, we can add silicon, we can add nitrogen, titanium, niobium, we can add a lot of different things. But what we do, we take these things, we melt them together and form a solution which is actually solid solution. Okay, so that solid solution, once again it has, if three components are there, then it is ternary, then four if quaternary, like this they have different okay, mm, stainless steels. So this is one thing. Now you can take another examples also. This is also known as alloy. Okay, okay, so what we do, we take once again all the alloys whatever we have heard about, like brass is there. Okay, let's talk about brass. So what does brass has? It has mainly zinc and copper. So copper is more, it is a primary metal, and then zinc is added to it. Okay, and once again they are made in such a way that you know uh, these things, they look very mixed together. Okay, and if you are wondering that what is brass in Hindi, most of us, they can uh, relate with that. It is known as Pital. Okay, all those nani dadis houses, we have that yellow colored uh, utensils that is made of Pital, that is called brass. Okay, next one you have bronze. Okay, bronze, right? You might have heard about bronze medal, right, which we get for the coming in the third place. Fine, that is bronze. It is also a homogeneous mixture, and bronze is surprisingly once again it is major metal is copper over here, about 80 to 90%, and then there is tin. Okay, tin is present. Okay, and bronze, what we call it in Hindi, we call it kansa. Okay, fine, kansa, we call it kansya, right? Few things, few different names of bronze. So these all are the examples of alloys. These are alloys, and all the alloys are solutions which are in solid form. Okay, there is one example which I told you, water and salt. You might have seen it a lot of time. It is saline solution, and saline solution or salt water or salt solution is liquid. Its state is liquid, so it is also known as liquid solution. There is a gaseous solution also. Okay, so if we talk about air, we have air around us. What is that air? It is a mixture of nitrogen gas, oxygen gas, and other gases also, like helium is there, argon is there, carbon dioxide is there, water vapors are there. But these are in traces, very little amount. Mostly nitrogen and oxygens are there. Now, if I talk about only pure air, okay, I'm talking about pure air, which is free from any kind of dust, any kind of bacteria, any suspension particle which is present in air. Okay, so if these gases are mixed together, fine, can you see the nitrogen and oxygen atoms separately? No, you can't see them. So what is there? They are homogeneous mixtures once again. Okay, once again they are homogeneous mixtures. Fine. So these are a few examples of homogeneous mixtures, or we can say solutions. So there are a lot of examples where we are using these solutions. Okay. All right. So this is a table showing various states of solutions and various type of solutions. So we have three main types of solution depending upon the state of the solution. First one is gaseous solutions. Okay, gaseous solutions are, you have to remember one thing, that state of solution, okay, it actually depends upon state of solvent only. Whatever your solute is going to be, it does not matter. State of solution depends upon the state of solvent. It matches with the state of solvent. Suppose your solvent is gas, your solution is going to be a gas. If your solvent is liquid, the solution is going to be a liquid. If your solvent is solid, then your solution is going to be solid. And you should also know that solution has two components, solute and solvent. Solvent is mostly present in the larger amount and solute is present in the smaller amount. So that is why the state of the solution is same as that of the solvent. Let's talk about our solutions now. Okay, first one is where solvent is in the gas form. In every case, solvent is going to be a gas form. So I have told you that if solvent is in gas form, then solution will be a gaseous solution. As you can see over here, it is written over here. Okay, so this has solute can be in the three different states of matter, which are the major states of matter, which is first one is gas. If gas solute is present in gas solvent, the example is air, and we are talking about pure air in which nitrogen, oxygen and other gases are mixed together. If solute is liquid but solvent is gas, okay, then it is humid oxygen, oxygen containing water. Okay, so if you add water vapors to oxygen, then it is going to be gaseous solution once again. Then solid in gas, solid solute in gaseous solvent. Okay, you can do a few things in that. You can take nitrogen gas and camphor is added to it. At normal temperature, camphor has a property to get sublime, okay, and it gets converted into gaseous form. So that gaseous camphor, when it is present in nitrogen gas, but the particles of camphor are going to be in solid form, individual particle. Okay, then there is liquid solution, when solvent is all liquid. Okay, but if solute is gas in liquid, then carbon dioxide which is dissolved in water, carbonated water or carbonated drinks, okay, whatever drinks you ate, like Coke, or I'm talking about Coca-Cola, okay, and all the other things, whatever carbonated or fizzy drinks are there. Then liquid in liquid, ethanol dissolved in water, okay, or mostly your sanitizer, liquid sanitizers, right? Then solid in liquid, that is salt water, we have known about it, sugar water, copper sulfate solution, anything. Okay, next is where all the solvents are in solid form, but solute can be gas, for example hydrogen gas, okay, and palladium. Now where we are using it, we are using it in the hydrogenation reaction. Okay, we are using it a hydrogenation reaction. You have done it in the class 10th also. Next is liquid in solid. Okay, solute is liquid but solvent is solid. So that is amalgam of potassium. Amalgam, whenever we are using, we are talking about mercury alloy. Okay, okay, we take mercury. Mercury is so difficult, to handle, that it reacts vigorously with every other metal. Okay, so mercury is used for dental fillings, amalgam of potassium. Now remember, when it is present in potassium, it is not harmful, but mercury alone is harmful. Okay, then solid in solid, that means solid solute, solid solvent, any kind of alloy. We have talked about a lot of things, right? We have talked about bronze, stainless steel, brass. Now there is gold alloy. Whenever we go to the jeweler always gives us, okay, this jewelry is 22 carat gold, or 20 carat gold, or 18 carat gold, right? So what is this 18 carat? So actually, whenever gold, we actually measure the purity of the gold, pure gold is said to be 24 carat gold. Okay, when copper or silver is added to that gold in a smaller amount, okay, percentages are different, then that gold becomes an alloy. Okay, so 22 carat, 20 carat, 18 carat, 10 carat, any kind of carat, when it is less than 24, it is going to be an alloy. Okay, an alloy is what? Alloy is an homogeneous mixture. And homogeneous mixture, what is that homogeneous mixture we are talking about? We are talking about solid solution. So that solid solution is going to be, these are a few examples. There are a lot of examples. You can take a lot of examples in that. Okay, the possibility is endless in this. Okay, so this is actually your solution. So these solutions, when they are mixed together, some of the solutions do not react with each other, but a lot of solutions, they do reactions. So those reactions, okay, whenever occur, okay, whenever we have to make a particular solution, we should know few things about them, and that is, first thing is concentration. Okay, so this whole topic was for the introduction of concentration. Now what is a concentration? It is the amount of solute present in given amount of solvent. Okay, amount of solute present in given amount of solvent for making solution is known as concentration. So actually concentration actually depends upon amount of solute, or we can also say the amount of one component. We can, do not define it like one particular substance, but we can say that it is a one component, the amount of one component present in the solution. Okay, so first concentration term which actually comes, that is known as percentage. Okay, or mass percentage. So today we are going to talk about mass percentage. How are you going to say that what this is a mass percentage? Mass percentage, obviously there are two words. Mass is the total amount of matter which is present inside, and percentage is actually whatever it is divided by 100%. Okay, so we have to use that formula. Now if we are talking about the mass percentage of one component, suppose there are two components. Okay, component A and component B. Okay, okay, the component A and component B are mixed together to form a solution. Okay, in this, if suppose you have been asked that what is the mass percentage of component A, then what are you going to do? You are going to take mass of component A divided by total mass of both the components multiplied by 100. So this is how the mass percentage is calculated. So suppose you have been given a few questions like 10 gram of sodium chloride is dissolved in 80 gram of water. Calculate the mass percentage, right? So we have to remember that which one is solute and which one is solvent. Lesser amount is sodium chloride, so it is going to be a solute, and there is more amount of 80 gram of water, so that is going to be a solvent. Okay, so mass of solute or NaCl over here is going to be 10 gram. Okay, then mass of solvent, okay, that is water over here, is going to be 80 gram. Now in the formula we had the total mass, so total mass is total mass of the solution, which is made by solute and solvent, obviously. So mass of solute plus mass of solvent, that is 10 gram plus 80 gram is going to be 90 gram. Okay, if you have been told to calculate the mass percentage, then it's going to be, what is that? The mass of solute, suppose mass percentage of sodium chloride is asked. Okay, then mass of solute, that is 10 gram, divided by total mass, that is 90 gram, multiplied by 100. Okay, gram and gram cancels, 0 and 0 cancels, and you get the answer 100 divided by 9, which is equal to 11.11. 1 is going to actually repeat itself. So mass percentage is, it's a term in the percentage. So percentage added, 11.11 gram, 11%. So this is how the mass percentage is calculated. Now you should know that where this mass percentage is used. Most of the time it is used in pharma industries. Whatever tablet you take for any kind of medicine, okay, in formation of that medicine, what we do, if we are making a solid medicine, which is a tablet or any kind of capsule, anything, okay, that particular thing has a percentage of given amounts. Okay, all right, so the mass percentage is used over there. Similarly, we have another percentage that is known as volume percentage. Okay, same way we are taking, but both the components are going to be in the liquid form or gaseous form, because we are measuring them in the volume. So volume percentage is going to be a volume percentage of, suppose component A we are taking, so that is volume of component A divided by total volume or volume of solution multiplied by 100. Okay, it is also represented as V and V percentage. Mass percentage on the other hand side is written as W by W percent. Most of the times whenever you see this kind of symbol on any kind of tablet or any kind of medicine, then you should remember this, that we have used weight by weight or mass percentage, or when this kind of symbol is used, then it is volume by volume percentage. One more is there, where mass volume percentage. Now what do we do over here? We take the mass of component which we want to take the percentage of component A, suppose, divided by volume of solution multiplied by 100, and this one is represented as a symbol of W by V%. Okay, most of the time this one is given in the suspensions. Okay, oral suspensions. If there are some oral suspensions, then in those suspensions, these are also once again medicines, or it can be anything. So weight by volume or mass by volume percentage has been taken. So this is how these things are calculated. And that's all for today. I hope you have understood the concepts and also gain the confidence in solving these type of questions based on percentage concentrations. We will be back with more explanation and more type of concentration terms in the next video. Till then, thank you so much for watching. Keep learning, keep practicing, and as always, keep ascending. See you in the next video.